Shalom class, welcome to Innocent MAPANDA tutorials. In today's lesson we are going to focus on question number 6, which was extracted from November 2018 Zimsec paper 2, pure mathematics. It reads, the line L1 has equation R is equals to 1, 2 minus 1 plus T 2, 1, 3. And the plane pi 1 passes through the points A, B, and C with coordinates 2, minus 1, 3, 4, 2, minus 5, and minus 1, 3, minus 2 respectively. Find, number 1, the Cartesian equation of pi 1, 5 marks, right? So I want you to notice something, right? Pi 1 is representing a plane, right? And if I'm to sketch the plane, we have 3 points which are lying on the plane. We have point A, point B, and point C, right? So what is the Cartesian equation of a plane? The Cartesian equation of a plane is in the form AX plus BY plus CZ is equals to D, where A, B, and C, right, denotes the normal vector of the plane, right? So to find the normal vector of the plane, you need to perform what you call cross product, right, of two vectors which are lying on that plane. For example, you can find vector AB and vector AC. Then you perform the cross product of AB and AC. If you perform the cross product of AB and AC, you will be able to identify the normal vector of that plane. I hope you are following, right? So let us start by calculating AB first. Right, so to calculate AB, we make use of the formula OB in front minus OA. I hope you are following. So what are the coordinates of B? The coordinates of B are 4, 2, minus 5. So we are going to write them as a position vector. You have 4, 2, and minus 5, something like this. Then you subtract with the column vector or the position vector of A, which is made up of the coordinates of A, which are 2, minus 1, and 3, something like this. I hope you are following. So 4 minus 2, you get 2. 2 minus minus 1, you get 3. Since negative and negative, they give you a positive result. Minus 5 minus 3, it gives you minus 8. So 2, 3, and minus 8 denotes the vector AB. We do the same to find AC, where AC is going to be calculated using the formula OC minus OA. I hope you are following. What is OC? OC is a position vector of C, which is made up of the coordinates of C, which are minus 1, 3, and minus 2. Then OA, we have 2, minus 1, and 3, something like this. Minus 1 minus 2, it gives you minus 3. I hope you are following. 3 minus minus 1, you get 4. Since minus and minus, they give you a positive result. Minus 2 minus 3, you get minus 5. Now that we have AC and AB, we now perform the cross product, which enables us to find the normal vector of the plane ABC. I hope you are following, class. Right. So, normal vector of the plane ABC is going to be found by performing the cross product. So when performing the cross product, you put I, J, and K at the top, then I plus j minus, and you put plus on k. Then you transpose vector AB and vector AC to create the second row and the third row. So I'm going to start by transposing AB. AB is 2, 3, and minus 8. So to transpose is to rewrite the column, but in form of a row. So you now have 2, 3, and minus 8, something like this. Then you do the same for AC. If we transpose AC, we get minus 3, 4, and minus 5. I hope you are following. So let us perform the cross product. So since we have a plus on top of I, we are going to take I as it is. Right? So like what I do when calculating the determinant for matrices, we have to find a 2 by 2 matrix of the numbers in the second row and third row, which are not aligned to I. So you write 3, minus 8, 4, and minus 5. Then on J we have a negative. So you put minus J here. So if we are to find a 2 by 2 matrix of numbers in the second row and third row which are not aligned to J, you will have 2, minus 8, minus 3, and minus 5. Then plus K. What do you have? You have 2, 3, minus 3, and 4. Like this. I hope you are following, class. Right. After that, we need to calculate the determinant of the 2 by 2 matrices. So when calculating the determinant, you start by multiplying the first diagonal. So 3 times minus 5, it gives you minus 15. Then before you multiply the second diagonal, you start by putting a negative sign. 4 times minus 8, you get minus 32. I hope you are following. Then you write minus J. We start with the first diagonal. 2 times minus 5, you get minus 10. I hope you are following. Then you put a negative sign so that you prepare the multiplication of the second diagonal, which is minus 3 and minus 8, you get 24. I hope you are following. Plus K. 2 times 4, you get 8. Then you put a negative. Minus 3 times 3, you get minus 9. Right. Then we move on. Normal vector is equal to I, open bracket. Right. So here we have minus 15 plus 32, which gives you 17. I hope you are following. Then minus J. Minus 10 minus 24, you get minus 34. I hope you are following, class. 8 minus 9, you get 17. So you write plus K, we have 17 here. So our normal vector is 17I plus 34J plus 17K, something like this. I hope you are following. So we would like to paste and copy the coefficient of I, the coefficient of J, and the coefficient of K in the Cartesian equation of the plane. Remember, the Cartesian equation of the plane is AX plus BY plus CZ is equal to D. So AX plus BY plus CZ is equal to D. A is 17, so you write 17X. Then B is 34, so plus 34Y. C is 17 plus 17 Z is equal to D. So to find D, you choose any point which is lying on the plane ABC. So you can choose A, you can choose B, you can choose C. Why? Because any point which is lying on ABC, if it is substituted on X, Y, and z to get the same value. I hope you are following. So we are given that a is equals to 2 minus 1 and 3. So I'm going to put 2 on x, minus 1 on y, and 3 on z to find d. So 17 open bracket 2 plus 34 open bracket minus 1 plus 17 open bracket 3, you get d. So 51 is equals to d. Therefore, our final answer is going to come out as this: 17x plus 34y plus 17z is equals to 51. Or you can write it as 17x plus 34y plus 17z minus 51 is equals to 0. Since 17 is a factor of all the numbers, 17 into 17 you get x, 17 into 34 you get 2, so this is 2y. 17 into 17 you get 1, so you will be left with the z. Then 17 into 51 it gives you 3, and this is your answer in its simplest form. Right, we are now on part A2. It reads, find the acute angle between pi 1 and L1. Right, so if you want to find an angle between a line versus a plane, we make use of sine theta. I hope you are following. But if you are finding an angle between a line versus a line, you make use of cos. A plane versus a plane, you make use of cos. But a plane versus a line, you make use of sine theta. Right. So I'm going to write sine theta here. Then I put a division line. On the numerator, I'm going to perform a dot product of the direction of the line and the normal vector of the plane. So the direction of the line is found in the second bracket, and we have 2, 1, and 3. Remember, this bracket denotes direction, and this one denotes a point on the line. So we need the direction bracket. We are going to perform a dot product with the normal vector of pi 1. So the normal vector of pi 1 is made up of the coefficients x, y, and z. So we are going to take 1, 2 here, and 1. I hope you are following. Right, so after that, you put the modulus. 2 squared plus 1 squared plus 3 squared. This is the modulus of the first bracket times 1 squared plus 2 squared plus 1 squared. Something like this. I hope you are following. Right, then I want you to notice something. Remember, when calculating pi 1, we got 17x plus 34y plus 17 z is equals to 51. So for normal vector, you can make use of 17, 34, and 17, or you can make use of 1, 2, and 1. You still get the same answer. I hope you are following. Right. So I have chosen 1, 2, and 1, which was the simplified Cartesian equation. Right. Sine theta is equals to 2 times 1, you get 2. 1 times 2, you get 2. 3 times 1, you get 3. This is the dot product. Then 2 squared plus 1 squared plus 3 squared, you get 14. Then 1 squared plus 2 squared plus 1 squared, you get 6. So you write sine theta is equals to 2 plus 2, you get 4 plus 3, it gives you 7. I hope you are following. Right. Then 14 times 6, you get 84. So you write square root of 84 here. Theta is equals to arc sine of 7 over square root of 84. 49,8. So your final answer is 49,8, which is the acute angle. I hope you are following class. Right. So I want you to stay tuned as we move on to part B of the question. The plane pi 2 has equation r dot 2 minus 1 minus 1 is equals to 6. The line L2 lies on pi 2 and is perpendicular to L1. So I have made a sketch which makes it easy to solve. I hope you are following. Right. So let this triangle represent pi 2. And pi 2 is r dot minus 1 minus 1 is equals to 6, which can be written as 2x minus x minus z is equals to 6. So we are being told by the question that L2 lies on pi 2. So let this side represent L2, since L2 is lying on this pi 2 plane. I hope you are following. And L2 is perpendicular to L1. So I have drawn a line which is forming 90 degrees with L2, and this line denotes L1. I hope you are following. Right. So remember, to find the equation of L2, the form we have, r is equals to bracket plus lambda bracket, something like this. This bracket represents any point which is lying on that line. And this bracket denotes the direction of the line. I hope you are following. So the point we are given by the question that L2 is passing through 4, 2, and 1. So I'm going to write 4, 2, and 1. Since 4, 2, and 1 is a point which is lying on L2. I hope you are following. Right. So we now need to find the direction of this line L2. So I want you to notice something. If this line is the normal vector of pi 2, right, we need to perform cross product of the normal vector of pi 2 with the direction of L1 to find the direction of L2. I hope you are following. If you have vector A, right, then vector B, right, and the vector C, performing cross product of A and B, you get C. If you perform cross product of B and C, you get A. If you perform cross product of A and C, you get B. I hope you are following. So same applies. Let this line at the corner denotes the normal vector of pi 2. And the direction of L1 is 2, 1, and 3. The normal vector is 2 minus 1 minus 1. So 2 minus 1 minus 1 and 2, 1, 3. If we perform a cross product of these two vectors, you will have the direction of L2. I hope you are following. So let me put I, J, and K. On I, put plus, J minus, on K, put plus. Right, then transpose the direction of the line. We have 2, 1, and 3, something like this. If you transpose the direction of the normal vector of pi 2, you have 2, minus 1, and minus 1. Would like to perform cross product to get the direction of L2. I hope you are following. So I is going to be multiplied by a 2 by 2 matrix of numbers in the second row and third row, which are not aligned to I. And those numbers are 1, 3, minus 1, minus 1. So you write 1, 3, minus 1, minus 1. Then you put minus J. The 2 by 2 is going to be 2, 2, 3, minus 1. 2, 2, 3, minus 1. Then you go for K. So the numbers not aligned to k in the second and third row are 2, 1, 2 minus 1. So you write 2, 1 and 2 minus 1. I hope you are following class, right? So the determinant here is 1 times minus 1, you get minus 1. Then minus, you put minus first, minus 1 times 3, you get minus 3. Then you write minus j. 2 times minus 1, you get minus 2. But before multiplying the second diagonal, put minus. So 2 times 3, it gives you 6 plus k. 2 times minus 1, you get minus 2. Then before you multiply 2 and 1, you start by putting a negative. 2 times 1, you get 2. I hope you are following. So now we have negative and negative, which gives us a plus. Minus 1 plus 3 is 2. So you write 2i, right? Then minus 2 minus 6, you get minus 8. With this negative, it produces 8j. Something like this. Minus 2 minus 2, you get minus 4. So this is minus 4k. And this is the normal vector. Right. This is the direction actually of L2. So you write 2. This one you put 8. And this one you put minus 4. I hope you are following class. Right. So this can also be reduced. If you write R is equals to 4, 2, 1 plus, you can factor out 2 as the highest common factor here. You get 2 lambda, 2 into 2, 1, 2 into 8, you get 4, 2 into minus 4, you get minus 2. So this 2 lambda can be represented by another constant, which can be 3. So you can write it as R is equals to 4, 2, 1, right? Or you can put even mu, then 1, 4, and minus 2, something like this. You can reduce the equation further. I hope you are following. Right, so I want you to stay tuned as we move on to the last question. Find the vector equation of the line of intersection of the planes pi 1 and pi 2, 4 marks. Right, so remember pi 1 was found in part 6a1 of the question, and we got x plus 2y plus z is equals to 3. Pi 2 is given in part b as r dot 2 minus 1 is equals to 6, which can be written in Cartesian form as 2x minus y minus z is equals to 6. Right. So to find the vector equation of the line, you need to know the form. You must have this bracket which represents any point lying on that vector line plus lambda. Then this bracket denotes the direction of that line. So you need to understand the form first. So let us start by identifying the point. So for the point, we are going to say, let z be equals to 0. So that we create simultaneous equation to find the x coordinate and the y coordinate. Right. So if we put z on 0 on z, on equation 1, you have 2x plus 2y is equals to 3, putting 0 on this z. On equation 2, you get 2x minus y is equals to 6 if you put 0 on minus z, something like this. We can make use of elimination method, multiply the top equation by 2, which is the coefficient of x in equation 2. Then multiply the bottom equation by 1, which is the coefficient of x in equation 1. So when multiplying by 2, you multiply both sides. So you have 2x plus the 4y is equals to 6, right? Then here you have 2x minus y is equals to 6. Then we want to less equation 1 with equation 2. So 2x minus 2x, you get 0. Minus and minus, you get plus. So this is 5y. I hope you are following class. Right? Then 6 minus 6, it gives you 0. So if you divide both sides by 5, y is equals to 0. I hope you are following. Then to find x, choose equation of your choice. We can choose x plus 2y is equals to 3. Then put 0 on y. 2 times 0 is 0. So it gives you x is equals to 3. So you put 3 on x, 0 on y, and 0 on z. So 3, 0, 0 represent the point which is lying on that line. Then to find the direction, you perform again the cross product, but this time around using the normal vector of pi 1 and pi 2. So this question was loaded with the cross product. I hope you are following. So I'm going to put I, j, and k, plus, minus, plus. So the normal vector, right, of pi 1 is made up of the coefficient of x, y, and z. So we have 1, 2, and 1, something like this. 1, 2, and 1. Transpose this, it gives you 1, right, 2, and 1. Then transpose pi 2 normal vector, you get 2, minus 1, and minus 1. Then perform your cross product. So I is going to be multiplied by 2, 1, minus 1, minus 1. Then you write minus j, which is going to be multiplied by 1, 2, 1, minus 1. Then you have plus k, which is going to be multiplied by 1, 2, 2, and minus 1. Something like this. I hope you are following. So 2 times minus 1, you get minus 2. Then you put negative sign so that you multiply the second diagonal. Minus 1 times 1, you get minus 1. 1 times minus 1, you get minus 1. Before you multiply the second diagonal, start by putting a negative sign. 2 times 1, you get 2. Plus k. 1 times minus 1, you get minus 1. Before you multiply the second diagonal, put a negative. 2 times 2, you get 4. So minus 2 plus 1, you get minus 1. So this is minus I. I hope you are following. Right. Then minus 1 minus 2, you get minus 3. But minus 3 times this negative, it becomes plus 3. So this is plus 3j. I hope you are following. Minus 1 minus 4, you get minus 5. So this is minus 5k. And this denotes the direction of the line. So the direction of the line becomes minus 1, 3, and minus 5. So I'm going to write here minus 1, 3, and minus 5. Then you are home and dry. So this is how you find the vector equation of the line at the point of intersection between two planes. I hope you enjoyed today's lesson. Thank you for watching. If you are watching for the first time, I kindly ask you to click the subscription button in red below and invite as many people to come and benefit from Innocent MAPANDA tutorials before their final exam. Till we meet again, Shalom.